Welcome back to Peanut Workshop. Tonight I'm going to start working on this Lightning McQueen. This is the Power Wheels version of the Lightning McQueen, not the Huffy version. So this comes with two 23-tooth pinion gearboxes. I've taken those out, taken the axle out, and that's where the modifications are going to begin. I have some bushings here to insert into the final gear that will fit tight on the axle. I have some bearings that I'm going to press into the gearboxes themselves to hold the gearboxes tight on the axle. I have the 887 motors and adapters to put on there, 23-tooth pinion gears, and then I've got one modified first gear here. So I'm not going to run a first gear delete. This is for the kids to run around in the yard. So I'm going to run a first gear, and when I run these motors with 23-tooth pinion gears, these gears end up melting pretty fast. So I drill them out and add some bearings. I'm going to show you guys how I put those bearings in just a minute. But let me show you kind of what the plan is here. So this gear I've modified with, this gearbox I've modified with bearings. So it doesn't have a lot of play back and forth, where this is just a normal, pretty worn out gearbox that has lots of play. Now, it's not the gearbox play that causes the biggest issue. As the wheels are moving around, it's moving that final drive gear around, and that's where I run into issues. Well, I have some worn out ones here, and you can see this final gear gets a lot of play in it. These are newer gearboxes, a little bit less play. I know this was one that was slipping. When you put too much force on it and you're going too fast, you end up warping it. Here you can kind of see on camera, I think. So this gearbox got too hot, it melted. What happens is the gear mesh for the final drive, it's not, you don't get a good gear mesh and you end up skipping gears. So that's what we're doing. So we're going to put bearings in the backside here. Here, let me grab the gearbox I've already modified. We're going to put that bushing in this final drive gear to hold that tight on the axle. And then pull this off. And then on the back side, we're going to drill that out and press a bearing in there too. And that's just to hold the gearbox centered with the final drive. So now all of the force and weight of the car should transfer right to these bearings, and we shouldn't have any issue of the final drive gear rubbing on the gearbox and heating it up. Now these are, I'm going to post the exact bearings I'm using in the description, but these are all 7/16 inner diameter bearings. The ones that are going in this bushing are 1 1/8 inch outer diameter, and then this back one I think is 0.9 inch outer diameter. But I'll put the exact bearings in the description if somebody else is interested in trying this. I haven't run this yet. Now, something you do have to do with these axles to fit these 7/16, there's 7/16. I have to put it in the drill and just take a couple thousandths off of it to get it to fit, to get the bearings to fit. Now, this is intended to be used for my kids driving around the yard, not really for racing. So what I am finding is the bearings do add a little bit more resistance. So when I'm spinning this gearbox, it spins just a little bit easier. Of course, the bearings are going to add a little bit of drag, so it is going to lose some performance here. You know, this definitely has more, takes a little more force to spin versus this gearbox, which is just a stock gearbox. It's definitely easier to rotate versus this one. That is something to keep in mind. This is definitely going to be a little bit more of a load on the motors. So we'll see how it works. We're going to start with pulling this gearbox apart, pulling the first gear out and modifying that. Let me get that done quick. These were stock motors. We basically just ran the car at 18 volts stock until something failed and one of the motors seized up. So now it's time to modify it. This is what a first gear looks like when you run 23 tooth pin gears with the 887 high RPM motors at, I think this was 24 volts. After just a couple minutes, that thing got disintegrated. The two main failures in the gearboxes we're trying to get rid of is the first gear melting at the shaft, and that I've had two different failures. I've had the gear itself fail, and then I've had the shaft just get so hot that the housing's melted. For first gear, we have to take it out, and we're going to use 3 different size drill bits. We're going to start with 1/4 inch, and then we're going to do 5/16, and then we're going to do a 3/8. So the bearings that I put in these are here somewhere. Here they are. So, and I'll add the exact bearing I use. I forget the inner diameter size, but the outer diameter is 3/8, so that's what I drill it to. I know one of them, I was at my dad's house and he had a machining drill bit set. So I did one size smaller than 3/8 and it pressed in better, but I've been using 3/8 and it's fine. And that's what this one was done with, and it spins nice. Now the other thing is you have to pull this shaft out. You're gonna have to put it in your drill and hit it with some emery cloth or some kind of sandpaper. Take a couple thousandths off it for it to slide nicely onto your bearings, or even to be able to get them on there. All right, first gear, let's wipe the grease off it. Starting with 1/4 inch, I'm gonna drill both sides. I don't drill all the way through. I just drill just enough for that bearing. First hole size. Now I do the 3 different sizes as I work my way up to the final size just to keep that hole centered. I'm using a drill press, so I don't have machining equipment, and it does have to be pretty precise to get those bearings to line up right. Next size, 5/16. And the final size, 3/8. Both gears are drilled out. Let's see if we can get the bearings in and if they're straight. So I have done this a few times where I did not get it lined up, and the shaft did not. But there we go. So that should be good. All right, so these are 2 different styles of bearings. One's sealed and one is not, it looks like. I'll put one of each in this gear, in this in the McQueen. Okay, so that is the first modification. Second modification, you can't put, this bushing is going to go into the final drive gear. This is tapered to match the taper of the final drive. It goes in. Now you can't put it all the way in. I wanted to get more bearing contact, so this takes 2 bearings, 1 on each side, and I wanted it as spread out as possible. So what I'm going to do is I'm going to take the Dremel tool and I'm going to slice off where this final drive gear used to ride and basically replace that with a bearing. Take a cutoff wheel on a Dremel and I run around it and it just comes right off. And I'm going to try and get less plastic shavings and everything, so I'm going to do it over here a little bit. Oh, there we are. And it just kind of melts the plastic, so I really don't feel like I got anything in the grease. So now I already have the bearings pressed into this one. All you do, I print these out of, I'm printing these out of PETG which is a pretty strong UV resistant plastic. Doesn't need to be UV resistant for this. It's just kind of the more durable filament that I have. So now you have to make sure it's in the right taper, and you press it in until it comes to the crown where the wheel adapter goes. Let's put that in, and there we go. So now that should be pressed right in the perfect spot. This should be able to go in the gearbox with no issue. Now, next step is 7/16 by, I believe it's 0.9 outer diameter bearing. I want to put that in on the back side of the housing to hold the housing center with the axle. Now that we're holding the final drive gear center with the axle, I want to hold the housing center with the axle. And there's pretty large tolerance on these holes. So to do that, I'm using a step bit, and I'm just going to step it because I want it tapered, because I'm going to press it in with the vise. So here's the step bit that I use. I'm just going to go one step at a time until I feel like it's the right size. All right, I got the drill press set up here. I wanted to make sure that this is level, so that when I'm boring this out, it's going to be nice and straight. So again, I'm just going to go up one at a time, test each time. All right, that looks like it's real close. I think that'll be good. Let me try pressing that in and see if it's going to go. And there we go. That is pressed in. I don't think it's going to come out. I need to go a little bit further. I think that's good. All right, now I should be able to assemble this gearbox back together. Oh, I need to pull this pin out. I just take a cloth, grab it with some panel locks, pulls right out. You see, take one of our gears. I can't put the shaft in it. All I do is put it in a drill and then grab some emery cloth. This is 80 grit, and just kind of run it in the drill on some emery cloth. Usually only takes a couple seconds, and then not quite yet. There we go. Push that back in. I'm not going to bother cleaning this out and replacing grease. I'm going to just use my grease gun. I use the red and tacky grease. So that's what this gearbox is going to get added to it. Yeah. I would like your comments on that. I looked in here. I don't see any plastic shavings. If you have plastic shavings in your gearbox, clearly you're going to have to clean that out. You do not want that. You want to get all these plastic bits out from shaving off your gearbox. But I think it's going to be good. I don't usually add a ton of grease. I just make sure that the teeth have enough in it. I usually give a squirt for each gear. I do use this stuff, the Super Lube. It's thinner. It seems to have a lot less resistance. I just have a grease gun of red and tacky, and that tube's empty. Now again, I'm trying this. I have no idea if this is going to work or not, or if it's even a good idea. And there we go. One 23 tooth pinion gearbox ready. I'm going to get the second gearbox all prepped, and then we're going to move on to the motors, putting the pinion gears on the motors, putting the adapter plates on the motors, putting the motors in the gearboxes, and then hopefully sometime this week I'll get time to install a speed controller in the McQueen. We're going to be running this McQueen at 40 volts with our 887 motors and this gearbox mod, and we're going to see how reliable it is. Our goal is to have simple upgrades with the parts we already have and make it so we don't have to take it apart again. I have both gearboxes done. Couple things that I found doing this modification. When you're pressing this bearing in the back, use a socket on this side, and then if you need to, you can use a socket to press this bushing in. So for this gearbox, I used a socket to press the bearing into the back side, and then I did end up having to use a socket to press the bushing into the final drive gear. Now, something I'm about to install the motors on here, and typically on the Power Wheel 7R gearboxes, you have to drill out the 775 drill hole. Somebody already did that. This was a used McQueen. Obviously, they don't make them anymore. So somebody must have already installed 775 motors in this McQueen before I bought it, and then put the stock motors back in it and sold it on Facebook Marketplace. Motor adapters. So we sell these motor adapters so that we can put these motors into 7R gearboxes. So there are nuts pressed into the backside, and these are M4 size, which match a 775 motor diameter and thread. And then these are M5s. So if you buy our adapter and hardware, this is what you get. You get the screws to screw this into the motor, and then you get these screws to screw through the gearbox enclosure into the adapter. And they're hex, so I got to get the right size. Now you take the slightly larger, farther apart hole, drive these through the gearboxes. 23 tooth pinion gears, that's the biggest you can fit in a stock Power Wheels gearbox. So this is a 32 pitch, 5mm shaft, 23 tooth pinion gears. So, motor that I put the adapter plate on. I'm gonna line that up. There's a notch for the set screw. You're gonna line that up there. For setting your pinion gear depth, you want to line it up with the first gear in here. You can just take a pair of cheap calipers, and that's going to tell you the distance from the inside of the gear to the edge of the motor plate, or the motor adapter. So that tells you how far out that pinion gear needs to be. For the set screw, I recommend using like an actual tool set's Allen wrench instead of the Allen wrench that comes with a lot of these pinion gear kits. They're really trash. Alright, so even though I went through all that effort to put that in place, I put a little bit of Loctite on the shaft. It's a smooth shaft, no notch. You can put a notch in it yourself, or one thing I used to do, I used to line it all up, drill a little hole in the shaft for the set screw to go into, and I've gotten lazy and don't do it anymore, and I haven't had any issue with my pinion gears slipping. I find just a little bit of Loctite on the shaft and tightening the set screw into the shaft. Now, see if I'll be able to turn this. Make sure nothing's bound up. Alright, there we go. First one done. I'll do the second one. And then there's one more step. So this shaft, I ground down one end. And as you can see, hopefully, I can get my modified gearboxes. It's going to take some effort to get the axle in to get all three bearings lined up. And I used we'll use a little encouragement with a hammer. So, this side goes on, this side kind of goes on, but it's real tight, and you're probably not going to get it off if you get all of them on. So what I have to do, I'm going to put this in the drill, and I'm going to hit this side with some emery cloth and take off a few thousandths of an inch and make it so this will slide nicer into the bearings. There we go. And the shaft's pretty hot, so as it cools, should make it a little bit easier. Here it is. The speed controller installed. Have reverse and forward. Have both motors. 2 pair of 10 gauge wire coming from battery compartment up here. I'm planning on running this one on 40 volts, so we'll see if I can fit 4 of the rigid batteries up here. I think I'll be able to. I have to pull the stock battery mount out. Maybe I have to cut out some of the plastic. Have variable pedal. And so far seems to run pretty smooth. So quick overview. What we did was we put 887 motors, 887 to 775 motor adapters, bearings in the first gear on both gearboxes, and then bearings in the final drive gear in both gearboxes, and then a bearing in each gearbox to hold it to the axle. We have Speedy Squirrel speed controller. This is good up to 40 volts. I got 2 pair 10 gauge feeding it from the battery compartment, and then 10 gauge going to each motor. I have just one switch in the gear selector for forward and reverse, no high or low. That's feeding into the left plus, left minus to detect forward versus reverse. And then we have the 12 volts out from the controller going to the gear selector to come back to tell direction. And we have a variable pedal. And that's it. I'm going to get this screwed together and let the kids test it tomorrow and see how it drives. Alright, here we are in 18 volts. Alright, here it is after running it tonight. The kids rode it. I checked the hour counter. It was half an hour, just around half an hour run time. That was on 40 volts. We ran 2 4 amp hour rigid batteries in series. I limited it to 75% and I changed the frequency to 15 kilohertz, and it ran pretty cool. It ran quick. It did about 12 miles per hour on the GPS. And let's look at these gearboxes. So yeah, after half an hour of runtime, which isn't a lot. I mean, I'm looking for hours of runtime with no failures. You know, these gearboxes are all tight to the axle. I'm happy with the way those bearings are working out. So remember, this was the bearing insert that we designed. I did 2 bearings, 1 on each side. I think the next one I do, I'm gonna pick one spot and do only 1 bearing. And then for this first gear, I've been running this for a while. I'll keep doing two bearings. Probably only need 1 bearing on the inside, but I've been doing 2 with no issues. And as far as this bearing, you know, that's just to hold the gearbox in place. No issues there so far. So if you're interested in following up on this to see how it's going, I plan to leave this configuration in for a long time to get an idea of how the gearboxes hold up with the added bearings. So just drop a comment when you see this video and ask how it's going, and I'll give a rough idea of how many hours are on it. We have the hour counter and the speed controller, so if I check the hour counter, I'll be able to tell you how many hours are on it. You know, currently, half an hour runtime, no issues. This thing ran really smooth and fast all night for the kids. They were enjoying it. So that's going to be it for this video. I hope you enjoyed it. I hope you're interested in modifying your 7R gearboxes, trying to get more life out of them before you go a different route. I know the aftermarket ones are pretty expensive. I have some myself, and if this is a good option for the kids running around the yard, I hope it works for everyone. I do want to bring up, if you're racing, it's probably not a good idea. This added a lot of drag. You know, like, this is off, and it's pretty hard to rotate the tires just because now you're overcoming the 2 bearings in this gear and the 2 bearings in this bushing. Yep, probably good to go with 1 bearing and 1 bearing, and I'm sure it would be just as good. All right, so that's it for this video. Make sure you like and subscribe, and I'll see you in the next video.